Hello everyone, it's October the 9th. As you guys can see, we are going to do word search number 2, hot question number 212 for today. Alright, let's take a look, see if we've done this before. Maybe. Submission. Oh, we have not done this before. Alright. Given an N by N board. We did a word search. It's a medium question a few days ago. Right? This one apparently is harder. Word return all words on the board. I'll return all words on the board. Each word must be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally and vertically neighboring. The same letter cell may not be used more than once in a word. Okay, so board is this, words is this. So we should return oath and eat, E-A-T, okay. 12 by 12. How is this different from the other one? Well, the other one is just to search, right? This one is to return. And again, it's path dependent, therefore we cannot cache it. So will be the same strategy for each one of them. So for each one, we're gonna search. Wow, then what? Then the rem time is rem times OMN times 3 to the this K, and then times how many times we have to do this? How many times I do this? Word's length is wait. We have 3 times 10 to the 4th. All the strings are unique. Wait. What are you saying? What are you saying is words.length, we have 3 times 10 to the 4th. If for each one of them we do the same strategy, apparently it can work. But then that's gonna time out for sure. Interesting. And the space is 12 by the maximum 12 by 12, right? So, and each word is smaller than 10 in length. I mean, again, we can do a pre-pruning, right? We just do the same thing. We get the counter of everything in here, and we do a counter for everything in here. 3 times 10 to the 4th, all right? Everything in here. And then, for each one, if there's no way of matching, then we just don't match. And for the ones that seem like we can match, then we run the algorithm. But that is still, what if every single one match? Well, every single one match, we have to go. I don't know, maybe we should go the other way around, because this is way too big, right? And if this say every word is unique, can we just like find the word? Well, that's way too many possibilities, right? Because each one can be the starting point. Each one can be the starting point. We have tons and tons of words that can be created in this. I mean, we can give it a shot, right? We can give it a shot. I mean, the running will be the same, right? The run will be the same. So basically, it's just we're finding the starting point and then try to search for it. But we can do, hold on. Pre-processing this list, sure. If some is a substring of other, how do you even determine that? Well, we can turn this into a try, right? We turn this into a try, and then And then what? Then we find the try. Yeah, every word is unique, but that's not a problem. We can create a try. So as we're matching for every single one, right? So we match, and then at a certain point we match, then we can return that word. At another point we match, we can return that word, okay? Yeah, a try to handle all the words. Then it's a prefix, so we're matching the prefix. So as we're matching the prefix, if we hit the end of the word, then it's good. Then that word is good, right? So imagine a try is just going to be, it's just a tree, right? You have a bunch of nodes, and then that's the root, and we can branch out however many we can branch out. So for the strategy is for every single one, right, for every single one, we need to, for every single one, we will search the starting point. For every starting point, right, for every starting point, we'll search. And then we're going to go through, right? So the next one, then we have different levels, right? And whenever we, I think we should give this a try, right? At least give this a shot. Let's see. Timeout is timeout, but this is a strategy. This is a strategy, and then I want to also see if I can implement this. It doesn't seem to be an easy implementation, this one. I mean, the good thing is yesterday, right? Yesterday we have that try problem, so I kind of learned the trick of using a default dict for try. So that's what we're gonna do today. So use default dict. So we're gonna use a default dict. All right, I'm gonna use default dict, and basically default dict is just like diff try, right? And then I can turn this into a lambda, right? I can say, is that a node? It's a try node equals lambda. No. Underscore try equals lambda default dict underscore try. And that is the trick. And then we're gonna say word count, right? Word count use the same trick as yesterday. It's in the iter tools, import chain, and this one will also need a counter. So this could equal to counter chain destruct board, right? Then we're gonna build the try for word in words, right? And then word count equals counter word, right? And then we say for word count in, just directly do this. We don't have to create another one. So this in this dot items. If word count W is smaller than C, then we break, right? Then we break. Else is this one completed, and then else. If you break, it won't hit here. Yeah, is that right? For else. Not. Let me double check. Python for else. For else. pythontips.com. It's a book. Loops integral part of any language, like for loops and blah blah blah. The else clause. Execute after the loop completes normally. Yeah, so if you have a breakpoint, we break out. Find something different. Yeah, that's exactly what we need. So if it's smaller than that, we don't do it. If it's not, then that means every letter in the word potentially can be found in board. Then we're going to build a try, right? And I'm going to say root equals try. Which is defined by the cell. So what I'm going to say is start a node equals root, right? And every time a new word comes in, this is every time a new word, there's a new word comes in, right? A new word comes in, we say node equals root, and then we're going to say for word in word, right? And then we say node w equals to a new try. I think that's the trick, right? It's equals to a new try. So I'm not 100% sure. I mean, it's fine. We checked it yesterday. So Python try default dict. Yeah, I forgot. I think this is the case. Yeah, because this is a new thing. We have to define it. Oh Lord, it's so slow. Come on, man. Slow internet. So slow. Nah, I mean at this point it's mostly not my internet. It's the laptop. The laptop is super slow. Okay, let's see. No, we don't have to. At just the beginning, would do this. And then when we add, we don't have to add this because it's already recursive defined, right? So node W is already a try. So we just need to say, okay. Yep, so we just need to say node equals this, blah, 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 blah. At the end, node, I like to say pound equals true, right? What do you use? Terminal. Node try terminal. We can just do that. Okay, we can just do node this and just check if this one is in it. Or, you know what? I like my way. This is to signal the end of a word. All right, so this is to build a try, and let's do step by step, which means we're gonna check it. Okay, step by step. Let's see if the try is built successfully. board is this, right? And then, as usual, please turn into this. Okay, and what's the word? What is this? Well, they do not have any common, so I think it's gonna save time for these. What's the other result? This is the result. Okay, this is the result. Okay, so that's our test case. Let me say board, words, answer. This is going to be find words, board, words. Then this will be sorted. What? All right, so can we just like print root? Take a look. Default dict. Oh, that is hard to see what it is. Yeah, that's fine. It's still transmitting. Well, just tell us anything, this thing. This function, lambda, add this to default dict, right? And then we have O, for the O-A-T-H. I think what I want to see is, yeah, let's try the one we have yesterday. I just want to see if this is correct. Now, oh my god, one way to try is to go the app and apple example we have. Right, let's just temporarily don't use this. Okay, so app and apple. Oh, what the hell? Oh, because let's yeah, that's correct, but I want to see app and l e. I think this is correct. All right, so we go back to our previous state. All right, you think this is correct? Now we have the try, which only include the words that are possible to be included inside a board. Now we're gonna just search for it, right? We're gonna search for it. So for each path, right? For each path, and we have a depth search, right? Depth search we have I, J, and then what else? So I, J, and we don't need a path. We're gonna use a board. We need a node, which is it's actually a default dict, and we're not returning anything, right? So how do we search? We search, right? So ij coming in. Ij is already the ones we're gonna look around ij, right? We'll look around ij. And move on to, so we look around ij. So node is the next one, right? Node is the next one. So we'll look around ij, and then if we find one that can fit the node, turn that to a dot, and then we go to that node. No, wait, we need to go to the next node. Wait, what is node? What is ij? So ij is pointing to the cell, which we already matched. That's why we go to the cell. Now I need to see the next one, right? Which is one of the next one in node, right? One of the next node, basically. That's one of the next node. So if it's good, we're gonna pass that node. So the node is pointing to these are pointing to the same thing. They're pointing to the same character. They're pointing to the same character. Need this to be sure. So eventually, if node will reach the end, so we go to the next node, all right, and then node has nothing. Oh. I should not say true. I know what this is a word, right? Word is going to be word. This is very important. So when we go to the end and we find the word, right? So we can take the word out immediately. So now when we go to the word, we just see if it's a word, we get it out, and we still search for the next one. And if there's nothing, then there's nothing. Right? So we shall start immediately for ning. And we have done this many times. So I plus 1, j, right? I minus 1, j, I, j plus 1, and I, j minus 1, right? So for this, for ning in this, if smaller equal to ni smaller equal to n, m, we need that. Before we go, m, n, it's LAN board 0. So this and 0 smaller equal to nj smaller to n, and we say board nj is not equal to dot. Right? If it's not equal to dot, then this one it was doable, right? We need to first go node. Oh, hold on. What do we say for each? Nah. This is first level is node. First level is node. We're gonna say for key, right? For key, next node, and then is next node, right? So key is just a letter, right? For letter, next node in node.items. If this is equal to word, right? Then rest.append. So we already found word. Node. Oh no, yeah, that's nn. Nn is the let's go to key value, easier. KV is easier. So KV, right? So if key is word, then we can go value because the value is the word itself, which means we need a res as well. All right. Else that's k and a node, right? So k and node. Then we can just go through this. Actually, more indentation. So else we're gonna try to match the key. So blah 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 blah. If this board is not equal to this, board is equal to key, right? If it's equal to key, then we can go that one. Therefore, what we do is we're gonna first say board. That's what I learned yesterday. We do nij here, right? Nij equals dot. Right? We set it to dot. And then we say search NINJ and V, because that's the next node, right? We search this. And after we search, doesn't matter, when we come back, backtrack, board NINJ become K again, right? Because it says equal to K, right? So come back, become K again. So basically we go 3 directions, right? And we try to see. Once we're done, come back, and then we try to find the next one. So that's that. So once we're all done, and just return. I mean, we don't return anything. We do not return anything. And every time, if it's a word, then we return. We append this. If not, we keep searching, searching, searching. Okay, so that's the search. Now we're gonna initiate the search, right? So we have the root. So we're gonna say for kv in root dot items, right? So we need to search for k, and we say for I in range m, right? For j in range n, and then we're gonna say if board ij is equal to k, right? And then we're gonna do board ij equal to dot, and search I j, right? Because that's the initial ij and v, right? ijv. Once we're done, we board ij equals back to k again, right? So it's similar to how this one is, but it's slightly different. Slightly different. Right? And then we go for all this k is the initial letter, right? We go for. So for all the initial letter, we try to find everybody, trying to get it. For the next one, everybody, and then we're just gonna return res. All right? Let's give this a shot. Run it. Okay, we pass, but with, oh my god, look at the time complexity. Let's copy and paste here. All right, console. Here's an example. Run code. Let's see how long it takes. Okay. 43. Do we dare? I mean, there's nothing to lose, so let's just go for it. Submit. Pending. Judging. Oh, it's so slow. Oh, we got a wrong answer. Oh, that's different. That's different. We have a wrong answer. How do we have output? OA, OAA. We have duplicate. Huh. We have duplicate. We have duplicate. How do we have duplicate? What's the word? What is OA and OAA, right? So we say OA and OA. This is troubling. This is troublesome. The whole point, right? The whole point of using try is to avoid duplicate, right? To avoid duplicate. And now we have duplicate. That is not looking good. Okay. All right. Don't panic. Let's make this solvable. We can always solve this. I'm more intrigued right now. Like how do we have duplicate? If I mean which is I think we got the try correct, right? We got the try correct. If we run this, yeah, we got duplicate. Jeez. All right, comment out this. Let's we come out this so we don't have to run. And all I want to do is print what root. So I just want to take a look. OA, right, and A, OA, that's fine. So as we search for the root is only one. We only have one root, which is O, right? We have O as, I see, because along the way, K is word and I append it, right? I mean, which means we just don't append. We take this as a set, right? We take this as a set. So we just call add, and then at the end we just return a list, right? A list. That you see, yeah, that will do to avoid duplicate. Or we can just check if it's in result, if it's in. But this seems to be easier. Okay, so again, yep. Okay, so duplicate, yeah, that it does happen. When you go try, it does happen. Now, another issue I just realized, right? So we go OA, we go O, we go A, but still, why would it? No. I don't think we have solved the problem. This is just hiding the symptoms. This root should only have one K, right? If it has one K, are we saying there are multiple ways to? That is an interesting one. All right, let's see. Let me draw this board out. This is an interesting one. I think what it is there are multiple ways to achieve OA, and I think I found both of them. 3, 4. 1, 2, 3. Right. So we have O, A, B, N, and O, T, A, E, and A, H, K, R, and A, F, L, V. Right. So OA. Yes, there are two OA. You have OA here and OA here. Therefore what? We need to start the larger word first. You see what I'm saying? We start with a larger word first. But how do we know? We don't. We just start from something and then we just go one by one, right? Or one by one, and then it just failed. And then we try another route and it succeeds. Yeah, so this is yeah, because on the try we only go one path. It's just there are two possibilities. There one possibility we hit it. So yeah, let's just try this using add. Okay, and go. Pending. Judging. And oh, we passed. This is a pretty tough one. But I kind of see how LeetCode is preparing us for this. Yesterday was try, remember? The day before yesterday was word search, which is a simple word search. So this problem basically is combine these two together. At least my solution is to combine these two together. And that's how we do it. All right. That's pretty good. We hit it the first shot, right? We hit it in the first shot. And it's not that complicated. Once we have been through those two problems. So yeah, I'm not sure. Right? I am not sure, but it seems like LeetCode was preparing us for this problem by asking us to solve a simple word search and implement a try in the previous 2 days. This problem, I solve this problem by combining, these two approaches. Now the reason, okay, let's do it this way. Looking at the constraints, right, of this problem, it has a word list as long as 3 times 10 to the 4th, right? So it is impossible. It is impossible to check every word, right? Check every word by itself. The only logical solution is to use a try such that we can hit multiple words, right? We have multiple words in one run, right? In one run. So that saves time. This will be extremely helpful in test cases such as we have A, right, and AA, and then AAA, and then AAAA, right? So will be very useful in this. Thus, we first build the try. Now, as we are building the try, we can also do a pruning, right? Or a pre-pruning. I just call it pre-pruning, right? We can do a pruning by checking whether a word is even possible to be found in board. And we use the same technique. We use the same pruning technique, method as word search. And after finishing all this, we have a try with all words in it, with always having a potential to be matched in the board. Then we just match the word, right? We just match the word by finding the starting point and then backtracking, right? And then backtracking. Now, one aspect that got me was that we need to use a set for result to avoid duplicates, because it is possible that a word can be found in multiple ways, right? In multiple ways. For instance, one of the test case with OA and OAA, right, has 2 ways in the board to match OA, right? To match OA. But since we always go down the longest path of word, we try to match OAA, and the first path matches OA. Yeah, I don't think I need to talk about this. That a word can be found in multiple ways. Right? We just say like this. That's fine. All right. What's the runtime? Well, it's mn 3 to the k, right? And we also need to have the total number of variable. So k is, let's say, average length of each word. and L, let's say L, right? So L is the length of word list, M, N are the row, are the number of rows and columns of board, K is the average length of each word. And we run this in 3 seconds. 3064 milliseconds or 66% ranking. Pretty good. All right, like this one and check to see how other people think. Complex numbers. Try solution with DFS. I think we're thinking about the same thing. I'm not sure if I want to look into Parkman's solution. Tree of words and also represent the board in a different way. Complex numbers. He likes to use complex numbers. Looking through all board positions. So Z in board and for 4 neighbors, 1 times J dot K. Okay, and I don't need to check borders because for the get just returns none. Here's a request. Let's take the tree and cursorily dive with it into each board position. I just search a single word, but with a tree instead. Yeah, I think he turns into a dictionary. I see. Let's see. So turn into a set default. That's another way. It's another way to do it. None equals to true. Then if no dot pop. Oh, I see what you're doing, Mr. Parkman. I see. Now we search the next position. Search with a none for Z, and search root and a Z and empty. I see. I see. That is smart. That is very, very smart. Oh, that is smart. That is very smart. What it says is once we find one, we just pop it, right? We're talking about a small word, right? When we found a small word, we simply pop it. So we don't have the word anymore. That's to avoid, right? That is to avoid using a dictionary, using a set. Jesus. Very good. Very, very good. Don't know how I think about it. That's good. Well, you can with practice. With practice. Yeah. Now the time is really not. This is beautiful. Exactly. Okay, so the trick. Yeah, this is the trick. This is the trick that got me. I mean, I have seen him, right? I have seen Mr. Parkman using complex numbers. I'm typing, but it's not showing. Come on, laptop. Don't do this. What the heck? Yeah. I want to comment, but I can't. All right. I'll let Chrome handle itself for now, but we're gonna make some changes. I mean, complex number, how should I say it? It's fine, right? It's fine, but it's not intuitive. I don't like it when it's not intuitive. But this is good. This is good. We use this, and every time we just say if node, right? This is basically a node dot pop word, right? A pop word and none. Just empty, right? Oh, hold on. So you have to record it. Oh, that's passing a word. No, we have different structure. We have different structure. So we're gonna say word equals this, right? And then if word, oh, it's different. I see. Oh, I have this. All right, so we have to do this first before we start. So we're gonna do this first, and pop out, right? And then we say if word, then rest.append word, right? And then, because we popped, then we don't have to check again. Or be like this. Because we popped, then we can use just rest, and then we can just return rest. Run it. Yeah. So update. Mr. Pachman's solution uses actively pops the end of the word signal sentinel. ¿Qué pasó? Jimbo, the destroyer. They probably ate something too. Or you gotta poop out those red things. I don't think so. He's an adult cat. It should be fine. Alright, so pops the end of the word sentinel such that each word will only be counted once. That's a very smart move. Very smart move. Very smart move. Alright. I don't think it's going to change the runtime though. I think it will be similar, but I'm curious. I'm curious on this one. I'm saying part of my using complex numbers before. Oh man, come on. Can't even comment. Before. Or comment later. Yeah, my CPU is crying right now because of the live streaming, and it's definitely not the best laptop right now. I mean, I've been having this for what, 2-3 years. This laptop is from 2015, no, 2014, so it's a very old laptop. So it's only natural that it behaves this way. Yeah, my cat loves it so much, and yeah, I'll put it in a review. That'll be fun. All right, again, try the console just to see everything's still working, and then when I submit it, I think it's gonna be faster, right? I think it's gonna be slightly faster because we don't have to compute the hashing, right? There's no hashing involved.